So this part of the video, we are going to look at writing and balancing chemical equations. Okay, so in a chemical reaction, reagents or your starting materials appear on the left side of the equation. The products will appear on the right. So we use an arrow to represent the reagents turning into products. Okay, we don't write this equal sign. So make sure you get all your chemical formulas correct for reagents. And then we don't change these formulas again. Okay, so what do we mean by this? Make sure your formula is correct. How do we make sure your formula is correct? Use the cross method of bringing down the charge to make sure your formula is correct. Okay, example, magnesium chloride. So bring down the charge, MgCl2. After that, you don't go and change the formula to Mg2Cl3, something like that. Okay, magnesium chloride stays as MgCl2. It does not change the formula. Okay, recall your common compounds, common covalent compound. So these memory word: ammonia, NH3, methane, CH4, and these diatoms, so elements that exist as two atoms, N2H2O2, and all your group 7. Okay, so we cannot create or destroy matter. So matter means all your atoms and elements. So any atoms that appear on the left, which is your reagent side, will appear on the right, which is your product side. So we balance the equation by counting the atoms such that the left side equal to the right side. Okay, if it is not equal, we balance it by using how many times of the molecule do we need to make it equal. Okay, this one means you add the coefficient, a big number. Okay, big number before the formula. You don't change the formula. Okay, when in balancing equations, please balance your matter first, hydrogen and oxygen last. Okay, hydrogen and oxygen, this is linked to many compounds. So usually balance it last, otherwise it's very complicated. Okay, and if your school teach you state symbol at lower sec, and state symbol must be written at upper sec. Okay, solid, liquid, gas. This is straightforward. Okay, there's a fourth state called the aqueous state. So AQ. So what does AQ means, right? So means I have NaCl. This is the salt in the kitchen, sodium chloride. I can have it solid. If I heat it until it melts, then it becomes liquid. Okay, and then if I boil the liquid, it becomes gas. Then I also can have NaCl aqueous. So aqueous, what does it mean? It means there's a beaker of water, and I put the solid salt inside, and it dissociates to the ions. It dissolves to become Na plus Cl minus. And this whole thing is NaCl aqueous. It is a solution and it is a mixture. Okay, so using this information, let's see how we write chemical equations. Okay, step 1, water formation. So be clear, this equation is asking me to write water forming. Forming water. Water is your product. Okay, don't write the opposite way. Okay, you have to write this way. So water formation. Okay, water is made up of its elements hydrogen, oxygen, because you know the formula is H2O. Okay, so hydrogen, the formula is H2, plus oxygen, the formula is O2. Give you H2O. So this step that I'm doing is to get all your formula correct. Okay, why is it H2 and O2? Please remember this, they are diatoms. Why are they diatoms? Because covalent bonding. This is noble gas configuration when they exist as two atoms. Okay, so after you write your formula all correct, then let's count it. There's 2 hydrogen atoms, 2 hydrogen. 2 oxygen atoms, only 1 oxygen. So what will you do? Will you go and change the formula H2O2? No, don't do this because H2O2 is not water. Okay, do you go and change the formula and cancel this? 2 from your oxygen? No, okay, because oxygen exists as two atoms, it doesn't exist as one atom. One atom is not stable. So I cannot go and change the formula after it's all correct. So what must you do? You must balance it by how many times the molecules do I need. Okay, so oxygen I have 2. To balance this, I need 2 times the water molecule. Okay, once you have 2 times the water molecule, then your hydrogen become total 4 atoms. So this part only got 2, so put another 2 times, 2 hydrogen molecules. And this is your final balance equation. Okay, in another example, let's say ammonia formation. So step 1 is to remember ammonia is NH3. So NH3 ammonia is made from nitrogen. Again, this is your diatom. Over here, they exist as 2 atoms, covalent bonding. Okay, plus hydrogen give me NH3 ammonia. Okay, so there's 2 nitrogen. I will put a 2, big 2 in front of the ammonia. Okay, and then if you put a big 2, there's 2 molecules of NH3, and total there will be 6 hydrogen atoms. So put a 3 in front of your H2. And this will be your final balance equation. Okay, if your school wants you to write state symbol, then hydrogen is a gas, simple covalent, low melting point, boiling point. Oxygen is a gas, water, you know it's liquid. Same thing, this is gas, gas,